A lot of our world relies on algorithms. But what are algorithms and why are they so important? Algorithms are step by step instructions or procedures that are used to perform tasks systematically and efficiently. Let's say we want to find the shortest path from S to T. There are so many paths we could take. Should we go through all of them and then find the fastest at the end? The problem with this is that it's very time consuming, and the more paths there are, the more complicated it is to keep track of. Luckily, we have dynamic programming. Dynamic programming isn't necessarily an algorithm, but rather a method or way of thinking. It's primarily used in computer science and mathematics to solve complex problems by breaking them down into smaller subproblems. And it's primarily used for optimizing. It's incredibly useful because it transforms problems that seem computationally expensive into more efficient and solvable
An
ones.
example and see how dynamic programming is used. Let's say you have a knapsack that can hold a fixed amount of weight and you have 5 items of varying size and value. How should you choose this? Let's look closely at this problem, so let's generalize it to make it applicable to varying amounts. We have n items to choose from, and that's our input, and we want to output the most valuable subset of items that fits in the knapsack. Some things to keep in mind are that for each item, there's a value vi and a weight wi, and that the capacity of the knapsack will denote as t. The circuit board depicted, there are subproblems within each larger system. Our subproblems can be divided into 2 cases. For items 1 through j, we want to look at the optimal value at that point to be the value of the optimal subset given our size restriction. Our only 2 cases can be if item j is in the optimal subset or item j isn't in the optimal subset. If item j is not in our optimal subset, our new problem is to look at the previous item with the same weight constraint as before. If item j is in a subset, then we need to look at the value of j plus the optimal solution for the next item that does not violate our new weight constraint. Use a recurrence. So a recurrence is an equation that expresses a term in one or more previous terms. Our recurrence summarizes our steps to determine the maximum value. This notation may be confusing, so let's break this down. The optimal value of a given item j with a capacity of s is equal to the maximum of our 2 subproblems, which is whether the item is or isn't in the subset. However, if the weight of the item is larger than the space left in the bag, it shouldn't be considered at all. And our 2 base cases are to consider whether there isn't any space left or whether there aren't any items left. Dynamic programming is a powerful and useful way to solve complex problems by breaking it down into smaller subproblems. It's applicable in so many ways and in day-to-day life. It can be used in fields like finance, AI, machine learning, logistics, and transportation.